Today we're going to do a skate park lesson. So, what do I have here? Skateboards. Okay, so I'm going to use these two ramps, and I want you to tell me which one hits the table fastest. Okay, so this is number 1 on this side, and this is number 2. Got it?
Got it.
Okay, so I'm going to go, let's count down. 1, 2, 3. Which one dropped first?
This one?
Number 2. Mary, why do you think number 2 dropped faster?
Maybe because the ramp is taller.
Ramp's taller. Okay, so that's a good prediction.
Okay guys, today for our activity we're going to be dealing with balanced and unbalanced forces. But before we begin, we need to discuss 2 vocabulary words. The first one is distance. What do you think distance means?
Separation between 2 points.
Very good. Distance is the separation between 2 points. Our second vocabulary word is velocity. Velocity is the amount of distance it takes to travel in a specific period of time. Just like when you're driving in a car, you go 60 miles per hour. But before we begin, we also need to pass out job cards. So as Clara passes around your job cards, I need the principal investigator to raise your hands. Awesome. You guys are going to be marking the 50 centimeter mark from the end of the ramp and measure from the top of the table to the bottom of the floor. Okay, if you are the safety monitor, raise your hands. Okay. You guys are going to be releasing the ball from the top of the ramp. Okay, and my materials managers, okay, you guys are going to be in charge of the stopwatch. You're going to be timing how long it takes the marble to reach the top and the bottom. And then my recorders, you're obviously going to be recording the data, but you're also going to be catching the marble at the end of the ramp. Now Miss Clara is going to be passing out a worksheet. When you get it, I want you to look at the question that asks why we have multiple trials. Why do you think it's important that we're going to do more than one test?
To have more data.
Have more data, exactly. Why do you think it's important for us to use the same setup each time we do the trial?
So that you can compare it.
Right, so we can actually get an average and our data will actually be more accurate. We're going to be doing 3 trials today. We're going to be doing 5 inches, 10 inches, and 15 inches. But before we begin, we need to know how to calculate the velocity of our marble. To do this, our equation is going to be velocity equals distance over time. So velocity is distance over the time it took to travel that distance. Okay, so now that you have your equation and your definitions, we're going to do the 5-inch ramp together as a class. So I am going to measure this ramp 5 inches. So I have my ruler, 5 inches off the ground. It's right here. I'm going to mark it. Okay. I'm going to take my ramp and my skateboard. We're going to face it towards the bottom so that it's going to fly off. Be careful when you do this, you don't need to hit anybody. Okay, and now I'm going to release my skateboard from the top.
And I'm going to use the stopwatch to measure how long it takes.
Okay. Let's count down, guys. Ready? 1, 2, 3. You divide distance by time, you will get the velocity of our skateboard. So now that you guys are ready, I want the materials manager to come up and get your materials, and you guys can start your investigation.
Remember that the distance is the height, not how far it goes.
So based on your observations that you had during your experiment today, what did you find the relationship between the height of the ramp and the velocity of your skateboard was?
The higher the ramp, the faster the velocity.
Very good. So the higher you made your ramp go, the more velocity your skateboard had. Exactly. Did you find that gravity changed as you made your ramp higher or lower?
No.
No, right. Gravity is going to stay consistent no matter how high your ramp is. So now we're going to introduce two more vocabulary words. The first one is potential energy. What do you think potential energy means? Potential.
What it has when it's at the top.
Right. So potential energy is energy stored while the object is not moving. So it's when your skateboard is right here at the top of your ramp. This is when it has the most potential energy. The second word is kinetic energy. Does anybody have any guesses on what they think kinetic energy is?
When it's moving.
Right. It's actually right there is when it has the most kinetic energy, when it's finished down the ramp and it's at its fastest point. So potential energy is energy stored in an object, and kinetic energy is energy of motion, so while your object is moving. Another way we can explore these types of forces is actually on a computer simulation. So I want you all to look at your laptops or computers, whichever one you have, and let's take a look at our simulation of our skate park. You're going to be working in pairs for this. We're going to pass out 2 new job cards. You're going to be either the driver or the navigator. What do you think the driver would do? Just like in a car, what does the driver of a car do?
Drives.
Right, so driving can consist of steering the wheel, pushing the brake pedal, turning on the blinker. So in this case, our driver is going to be controlling the operations on the computer. Where else have you heard of a navigator?
When you're going on a trip.
Right, so specifically on a boat, there's always a navigator on a boat, and the navigator tells the captain or the driver where to go. So in this case, our navigator is going to be reading the directions for the driver. Okay. So let's go ahead and pull up our simulation. We're going to go ahead and pull this up, and as soon as it's on there, I want you guys to start the simulation.
Okay guys, can you put your laptops or whatever electronic you have at half mast and look up here so we can talk about what we just discovered. So, what happened when the skater rolled down the ramp?
He got faster as he went down.
Right, so at what point do you think he had the greatest potential energy?
Right at the top of the ramp.
At the top, right? So then where do you think he had the greatest kinetic energy?
Down at the bottom of the
Down
ramp.
at the bottom of the ramp. Was it his fastest point where he had the most kinetic energy?
Yes.
Good. Okay, so what evidence do you have that his potential energy was the most up here?
The speedometer.
Right, so you had a speedometer and it made a graph. So that's where you saw your evidence. So when potential energy went down, what went up?
The speed.
The speed, which means what type of energy increased as potential energy decreased?
Kinetic.
Kinetic energy. So potential energy actually transformed into kinetic energy as you rolled down the skate ramp. Okay, so when it does that, it's an energy transformation. And that's one of our vocabulary words. So when you're looking at potential and kinetic energy, there's also total energy. So what do you think happens to the total energy when there's energy transformation?
It gets conserved.
Right, so it stays the same. That's a really good observation. So what the law that we have that says that energy is only transformed, it's never
created.
right, it's never created or destroyed, it's only transformed, is called the law of conservation of energy. So, when you started at high, you had higher potential energy, right? So, we already looked at the definition of potential energy. What does potential mean? So, if potential energy definition is the stored amount of energy in an object that's not moving, what do you think potential means?
The stored part?
Right, stored. Potential means stored. So that's how you can remember that potential is the stored energy And kinetic energy is when it's moving, so that's kinetic energy is the energy of motion. Awesome. So say I'm holding my skateboard up in the air. What's acting on it?
Gravity.
Gravity, right. So if I was to let go, what would happen?
It would fall down.
Right, and that's gravity acting on the skateboard. So when I hold my skateboard up here on the ramp, it also has gravitational potential energy. Can anyone think what gravitational potential energy means?
The stored energy that gravity has at the top of the ramp.
Right, so gravitational potential energy is the potential energy due to gravity pushing on it. Awesome. There's also other types of potential energy, like chemical potential energy, and that is the amount of energy stored in the chemical bonds between molecules, and elastic potential energy. Like if you've ever played with a slinky, you pull it apart, it has a very big potential energy to go back to how it was before you stretched it out. So speed, or like velocity, which you studied, relates to potential and kinetic energy. So I think Mary helped you and asked you before, what happens to the speed as the potential energy decreases?
It increases.
Right, so as speed increases, what increases if potential energy is going down?
Kinetic energy.
Right, so potential energy goes down, kinetic energy goes up, and so does the speed. And that's what you guys found in your Explore. So how can we change the total energy of this experiment? Because we're doing it without any other forces or things that would take energy away. We're just doing kinetic to potential. But that's not how it works in real life. So what do you think are some things that would maybe slow it down and make the total energy of the actual skateboard go away?
Friction.
Decrease. Friction, right. And friction wasn't on your simulation. So friction makes it slow down. So even though it may have a ton of potential energy, it's not going to all convert to kinetic energy because some is going to be taken away by friction. So what can you change, maybe on the simulation, that would change the total energy? Maybe how heavy this is, right? Or what if we change the track?
Could make it smoother.
Make it smoother. So different tracks have different frictions, and that would help it with the total energy and conserving that total energy to make it all go to kinetic instead of potential. And that's what we want, but it's not always possible in real life. So what were some good things about the simulation?
It was easy to control.
It's easy to control. What are some bad things about the simulation that could have been better for our experiment?
It was only two-dimensional.
It was only two-dimensional, right. Also, did it account for friction?
No.
It didn't account for friction, right? So sometimes we have to use things that are ideal in order to learn about them, and then we can put into the fact that friction does occur, and in real life, like we were using the skateboard, all of this potential energy doesn't go to kinetic energy because of friction and other forces.
Hey guys, who here has ridden a slide that looks like this one? Awesome, a lot of you. So what kind of forces do you think are acting on you as you go down a slide like this one?
Potential.
Potential, okay. Just like our ramp, you have to start at the top. What else as you're moving down the ramp?
Kinetic energy.
Kinetic energy, right. How many of you have ridden a really tall roller coaster like extremely tall.
Neat.
Yeah? Awesome. So have you noticed that the higher the roller coaster, the faster you go down? Just like our ramp with the skateboard, the higher we made the ramp, the faster our skateboard went. But what about water rides? What other forces could be acting on you as you're going down the slide?
Gravity.
Okay, gravity, right? But if this is a water slide, what else could be acting on it besides the gravity?
Water motion.
Water. The water is helping carry down these people on their slide. So we're actually going to make our own today. Since we don't have a slide big enough to fit actual people, we made a person. This is our person, and he's on his little slide just like these people. Okay, and this is our water slide. So this is what it looks like without water. Okay, ready? I'm going to let him go. 1, 2, 3. What happened?
Nothing.
He got stuck. He didn't go anywhere. That's not a very fun ride. But what about if we add some water? Let's see what happens. So I'm going to use my water bottle. Okay? And Miss Claire is going to pour some water. Whoop, I dropped our guy. Pour some water down our slide, and then I'm going to let him go. So what happened?
It moved faster, right? It actually got down the
He
slide.
actually got to complete his slide. So the motion that the water's putting on somebody when they're going down a slide like that actually helps them go down the slide. In this case, what did the water help reduce on our slide?
Friction.
Right, there's less friction getting in the way of our little blue guy on his slide because the water's helping move him and absorb some of that friction. Okay guys, now it's time to show off what you know. We're going to pass around the quiz, and remember this is independent work. So we're going to give you guys 2 minutes, and then we're going to come together and answer the questions. Okay guys, your 2 minutes is up, so I need eyes up front, and now we're going to go over the show off what you know. So question number 1 reads, what does gravitational potential energy depend on? What did you guys get for that?
D.
D. D is both position and gravity. That's correct. Very good job, guys. What about number 2? A tiny pig that is dropped from the top of a building will have an increase in what type or types of energy as it falls?
Kinetic energy.
Very good. So remember, kinetic energy is the energy of motion. Okay. Number 3, the following is a graph of the energy of a skateboarder as he travels down a track. Using the diagram on the left, at which point on the track does the graph correspond to?
B.
Very good. At point B, what does he have the most energy in?
They're equal.
They're equal. Very good. Okay, and then our last one, question 4. Katie wants to design a roller coaster where the passenger is traveling super fast at the bottom. What characteristics should the roller coaster have?
B.
B. It should have very little friction, just nothing to slow it down. And the passenger should start off super high above the ground. This way the passenger starts out with a lot of the potential energy that can be transformed into her kinetic energy, which means a faster speed. Thank you guys for joining us. That's all we have for this lesson, and we will see you next time.